So I hope you can hear me when I'm back. Is that okay?
No problem.
Good. Oh, so maybe I'm talking to the microphone as well. Let's see what happens now. Oh, that was nice. So I will not go so far with my computer because it's just really slides. So my name is Janus. I'm from the Alexandra Institute, and I'm going to try to convince you why cloud computing will become the golden age of cryptography. So what I'm going to talk about today is sure. Great. So the agenda for today is security in relation to storage in the cloud and computation in the cloud. So look at these two in terms. So first of all, the Alexandra Institute is a private company where we try to, help other companies leverage academic research in their product development. And we basically focus on IT, which is all of IT, and we have some special focus areas. And I'm with the security lab. So security in the cloud setting is perceived by people to be interesting, to say it mildly, or challenging to be, maybe more exact. So this is a survey where security is ranked as one of the top challenges in cloud computing. Just to make you aware that maybe there's something about the security, and I hope to convince you that something can be done about it. So let's look at some attack vectors in cloud setting. So we have the usual suspects like insiders and outsiders, and also like, you have your platform and stuff like that, but you also have your provider, and the provider's security, infrastructure, guarantees, and stuff like that. And then you have, then the new thing here, compared to if you host your own data center, is you have neighbors, which is something some of us are familiar with, at least privately. But in this setting, it's a kind of new thing, where, for instance, you have, I don't know if some of you may have heard about Dropbox having a slight issue with neighbors, at least the users' neighbors, or the users' data, where some users were able to access the data of other users. So there was also all sorts of interesting cases where you can use like side channel attacks. For instance, if you run on the same physical hardware and you're able to detect key material, stuff like that, based on timing attacks on the CPU and stuff like that of the other neighbors you're running with. So at least in theory that's possible. I don't know if anybody actually managed to do it in practice. So let's look at an example. So this Dropbox case, if you upload a file to Dropbox, then Dropbox is probably going to guarantee you that they're going to probably encrypt it and store and keep it as they best can and should do. However, you have to trust Dropbox that they do not actually hack your data over to other people or screw up the security, or what happens if some government comes to Dropbox and says, oh, I want this user's data. Then what? So if it's my personal papers and stuff like that, then maybe, I don't know, I'm kind of, well, that might not be a problem. But if it's a company's trade secrets and stuff like that, then you might be, oh no, that's not so good. So a apparently totally benign solution would be to encrypt your data before you send it to Dropbox. Hey, that's cool. Let's use some cryptography. Of course you want that to be transparent and easy to use and stuff like that. That's what the people want. And if you encrypt it before sending it to Dropbox, then Dropbox will not be able to use it too much. So they reduce their attack possibilities to basically say, oh, we got the data, oh, we don't want to give it back to you. But if anybody else comes along and get access to the Dropbox account, then they just see rubbish. At least if you use a sufficiently strong key, which you should. However, if you have another client, for instance, if you have an Android phone, or you just have multiple users who want to share the same data, then you get all this hassle of key sharing. So what we did at the Alexandra Institute is to show that this is actually a feasible thing to do. We made a demo where we use QR codes to transfer the key material from the desktop client to the phone. So this is a basically really simple and benign solution to this problem. At least if you can meet together and exchange the key material in a easy way. Yeah, you have to meet physically basically in order to scan the QR code. So that might not be a solution which is like doable, and if you want to, for instance, ship the key to another place in the world, then you get all the problems you usually have with storing key material. So you might not want to send it via email to a foreign office, and ship it via FedEx or USB may or may not be a solution. I don't know. You can always put somebody in flight, but then they might get stopped at the border and copied and stuff like that. Maybe, maybe not. At least if you're paranoid, there's all sorts of solutions or problems you haven't taken into account. So another solution would be to encrypt. So another solution would be to have like a client encrypt the data using his private key, and then we have a cloud provider with some storage up there. Ship the data to the cloud provider. Okay. Then we take some other cloud provider, preferably some cloud provider which you're pretty sure would never cooperate with the other one. So if you got a data center in Iran and the US, then that would be a good thing, at least with the current geopolitical situation. I don't know if you can get such a good access, but yeah. So at least you have to find somebody you believe are mutually distrusting. So you upload the data encrypted as well to the other party, and then the neat trick is to split the key among the two parties. So now you basically delete the key from the client, and now you can have multiple clients access your data without having a key. They only need the credentials for the cloud providers, but that might be easier for you to administer. So if you want to get your data back, then you just log in, download each key part, reconstruct the key, download the data, and decrypt it. So this is so one thing which is bad about this is that if one of the parties is saying, "Oh no, I'm not going to give you back your data," then you're screwed. Just as much as you screwed before. But if you, for instance, take a third party, a third provider in, then you can actually construct this in such a way that you only need 2 parts out of 3, for instance, of the keys in order to reconstruct it. And then you actually get something very nice. You get easy access to the key and data. Oh, whoops. But you also get redundancy. If you have like 3 providers, then at least one of them can say, or go bankrupt or say, "I don't want to give you your data," and you say, "Oh, that's a pity for you. I still got my data." So that's a possibility for like cryptography, so it's also one of our nice new problems. So let's take a look at computation in the cloud. So usually you have some data, some clients input some data to your service, and they usually do it probably if you come to this this point where I'm talking about, then you usually use like SSL or something in order to make a secure channel to this web server, and then you basically encrypted it either on the client or on the server. Probably you should encrypt it on the client. That would be probably the most preferable thing. And then you store it, encrypt it on the cloud provider. But then you want to compute on it. Okay, so then you're going to decrypt it on the cloud provider. But if you're afraid that the cloud provider might be malicious, might be willing to inspect your data while it's stored, and that's why you encrypted it, then they can also take a snapshot of your computer while it's running and take a snapshot of the RAM and first take your data. So that might not be what you really want. Another option is to host the computation back home in the data center, but then you kind of lose the advantages of cloud computing. So what you can do is another scenario which we call deep confidentiality. You have the same setup, you have a web server, you have a cloud provider, and you have a storage. And then you don't decrypt the data. Instead, you distribute the computation among cloud providers in such a way that again, you have to find some cloud providers that you believe would not work together, or at least you make sure that it's even more complicated to reconstruct the computer values or the encrypted values. So in this case, you have three computers, three instances working together to solve our problems from before, do our computation, and then use some clever crypto stuff that you can talk to me about afterwards if you really want to know. And it all happens encrypted, so nobody knows. Of course, if you compromise all three parties, then you would get to know the data. But if people don't do that, then you wouldn't know. And each of the three parties wouldn't know each of them. So this is actually really cool. And it gives you a lot of security, but it sucks really much on performance. So, for instance, like a multiplication is like a factor of 10,000 slower than a multiplication on a current commodity hardware. So that's kind of slow. I think it's really fast, but that's kind of slow. Yeah. So you have to. So it's only currently it's only in very specific situations that this is actually a doable solution. I will grant you that because it's so slow. But they actually exist. So one of them is a case study that we made for a company called Energy Auction. They have this site where, for instance, bakers or pizza bakers or basically small to medium-sized energy consumers can go and auction their energy usage to energy providers, and they can bid on it. So it's kind of an auction house. So they would, so baker, for instance, would define an auction, and then the energy providers would bid on it. And in this case, the energy providers are really don't want the other providers to know about how much the bid was, and that can be ensured to confidential using this technique as well. But this auction only has to run like once a day. So for instance, like for 2 hours, there's plenty of time to do this auction, even with a modest load. Yeah, they make the deal. So this is actually doable, and it's running in real life. So I hope I kind of give you a glimpse that there are some cryptographic techniques that can actually solve some of these problems that are really interesting for cloud security. And we have this Dropbox table which you can get from Android Market, and we also have a cloud security course which those of you at GoTo can enter a contest and win a 3 days course. So thank you.